Hello folks, and welcome to CrystalMind Chronicles. I'm Kieran Dave, and today I'm hanging out, spending a little bit of luxury time in my golden bed. Because that's what this is all about. Luxury for me. Well, maybe it's just that I've been playing with this personal shrinking device, which is really fun. But maybe that's enough playtime for now. After all, we have work to do. Now, I have been filling up the crafting interfaces on these, and I wanted to automate a bunch of create recipes. So as you can see, in addition to the integrated dynamics recipes, there are create recipes here now too. And I'll be needing those fairly soon because I have been putting together project kits for the 2 projects coming up. We're going to be working on, I think next, a auto throttle of power. Right? And so that's in this box, which is what we're going to concern ourselves with today. Then I also am using an awful lot of mineral. Like I said, it's kind of hard to process. If we go ahead and take a look at mineral, we'll see that there is just not a lot of ways to actually grow the tree. There is, let's see if we can find, there's basically no way other than, well, not even this, right? Like, there's no way to grow the tree automatically. We have nothing there. Whereas if we were to look at, say, a spruce tree, right, we could see the phytogenic insulator would let us grow the spruce. And I thought that I would be able to do that, if I'm honest. But it turns out I can't. So after we finish making our reactor upgraded and fully automatic and moving our machines out of this room, in this space, which I've been working on, I'm not sure how I feel about it, but we're going to do that, and then we'll work on the mineral farm, which I've also made a full kit for. So this room will be where the machines go. This room is where the reactor is going to get moved to, and you can see we're actually cutting into the bottom of the geode here. I'm not sure what I'm going to do about that, if I'm honest. But I sort of enjoy these LED lights. The texture's just cute. I wouldn't say they're the most beautiful lighting block we have access to, but I'm kind of digging the vibe. So yeah, I think that they'll do for now. I haven't done too much down this way other than just repave the floors. And oh, that's right. One thing to mention is between the last episode and this one, you'll notice that I don't have my pick anymore. I did manage to cut a shaft up to the surface right over here. And you can see there's a death mark here. There's no reason why that might have happened. And that goes all the way to the surface, and there's a little roof to keep the rain out, and there's some fences to keep the mobs away. I did it with a turtle. I think it's still in my backpack. Yeah. When I broke that turtle, it was the last use on my fancy Tinker's pickaxe. And it broke. And it broke like a regular tool and went away, and I couldn't repair it. I'm not pleased about that. But in the meantime, I did make a flux spore. And I had some enchantment books lying around because, as you know, I've been fighting bosses on the surface, and they give me just an absolute boatload of enchants. In fact, ooh, I didn't even realize we have capacity 3. But for now, let's go ahead and get started on our reactor build. The first thing I'm going to have to do, how about right here? There we go. Is I'm going to have to, well, you know, I kind of want it facing the other way. Thanks. I'm going to pull the reactor out of the wall. I'm going to move our redstone flux cell, which is our primary power right now, and all of this other stuff. Move it out of the wall, and you can see I have some extra blocks to make it bigger. And have an extra fuel rod, and also have a block of gold as a moderator. Let me go ahead and pull it out of the wall, and then I'll show you exactly how I'm going to assemble it. We're going to make a slightly better reactor that has more room for automation. And this is just pretty easy. I'm very sorry to all of the uranium I just lost, but we'll be fine. What are you doing in there? What, that's a reactor casing, and parts of it have been used. You should get out of there. You should get out of there. All right, just kidding. Oh wow, I'm hungry, aren't I? I really, really love egg sandwiches. I'm just gonna say, seriously amazing. Let me just top it off though. You know, as one does, egg sandwich and a baked potato really start my day. I'm also going to start up the reactor in just a moment. We're just going to put in the final touches here. So these are the control rods. I've opted for 2 with this design because, frankly, I'm still a little bit low on sand, and that's actually kind of what's gating this. I have plenty of iron. We're going to use gold as a moderator. I think it will be okay. And then I need this last piece of reactor casing, and these 2. And I think that, yes, look, it recognized the multi-block. Hopefully this multi-block will be more stable than the previous one. I don't know. I rebuilt it now. So there's nothing in here. Let's go ahead and give it a little test, though. I put a bar of uranium. We should actually grab a little bit more. Can't really tell anything about the nature of this stack, right? And we'll go back over here. And there's a reason everything's back over here, by the way. So this place will be the... We'll say this is the inserter. I think that's the right call. There we go. Now the reactor's full. Let's see what its maximum power is, right? If I did my math right, we should be hovering up, or we'll top out just before 500. Yeah, perfect. And this actually is more efficient than the previous reactor. It's consuming a little bit less. So I'm pretty happy with this. This is, again, a simple design and a small amount of power, but definitely exceeds our needs. And I sort of dig like just seeing the gold block in there sort of makes it feel very premium. Now, the other thing I said was that we're going to have energy storage in this room. And for now, that's going to continue to be our redstone flux cell. So I'm going to go ahead and put that, let's see, where should I put it? You know, for simplicity's sake, I think we're going to keep it over here for now, in the wall. We'll go ahead and cut these out. And we'll need to cut out the floor in just a minute, but I'm not going to get ahead of myself here. And let me go through here and just change some of these settings a little bit so that we can start from a fresh place. There we go. So what we need to do is basically I'm going to be putting more and more storage into this wall. This will be our power storage wall. And I don't want to have to rebuild my automation every single time that I update my storage, right? If I go and I grab that capacity book from the chest and I put that over here, on this thing, well then do I have to redo all my numbers? No, we're going to be using integrated dynamics. And the first thing I think that maybe people don't know is that integrated dynamics is essentially the... Whoa. Wow, there's a giant hole right here. There's a giant hole right here. I guess I'll fill this in. I mean, obviously I was here, but I have no memory. I was tired and I was on painkillers and I filled in the hole. Right where I was going to be working. All right, that's filled in. So this, people don't know, but integrated dynamics is probably one of the most powerful power movement mods that we have access to. If we go ahead and set the very bottom here to input and output, that gives the network with this energy interface access to this like it's a battery. The interfaces work an awful lot like the item interfaces that we have in storage back over there, meaning that the system will treat it as sort of part of the network, right? And so now we have this basically become part of its own tiny little network. And if we were to, say, walk over here, let's just go ahead and leave this on for a minute to fill up. And we can put these, and we'll fill in all this with facades in a moment. But if we put this, where's the flux power tap? We want to put that over here. And go up like so. And get an energy importer. Toss that in. And then I think we need, yeah, our variables. We just want to tell this always import energy. So we put that there. An empty evaluates to true, right? And ta-da, we are going to be, or at least we should be in a moment. My bad. So this is an active power tap. And what we actually want is a passive power tap for these purposes. The active power tap was why it could push to the redstone flux cell. Simple mistake, my bad, but something to watch out for, I suppose, if you're going to try to build along at home. Anyways, let's connect this back up. And now let's hope that I'm right. Import energy. Yeah, power's going down, power's going up. Perfect. All right, so then what we have next to look at is a redstone port for the reactor. You can see that basically I can tell it, I want you to set your on-off status based on the redstone signal. And if we put a redstone writer on there, which I think we have one. Yeah, we have it right here. Right. Put that there. Run this here. Now, if I were to go ahead and right-click this and then just say, I don't know, let's use another default here. That will mean redstone on forever, right? And we should see that the, let's see, the power should be set. Yeah, it says it should be on. Save. Okay. So yeah, now it should be on. Yeah, and it's generating power, and it's dumping that power out immediately into our system. And I don't think we actually have the power. Okay, we can force it to turn off there. And I think now we have to go back in here and save from set from signal. But let's go ahead and turn that off, right? And now it should not be running. It should not be powering up anymore. Yeah, we're basically... Let's see. This reactor's a little... Yeah, it's off. It's off. It just was draining its buffer. Okay, so these reactors are not like instant machines. They prefer to be sort of run up, get hot, do as much work as they can, and then, you know, turn off. So, or run constantly. They're much better in that mode. So that's what we're going to try and set up. I'm going to put a picture because it's kind of hard to explain this. This is actually like my third take trying to explain how we're going to do it. So I'm just going to show a picture. We've got 2 inflection points. When the reactor is below 20%, we want to start working. When the reactor gets above 80%, we want to stop working. But that means we've got this big section between 80 and 20 where we could be in either state. We're going to have logic to fix that. So I went and I got a program. That's right. I got an integrated dynamics program and I wrote it all out and I'm going to put it on the screen here. And I'm also going to put this in a link in the description so that you can look at it. But essentially we're going to recreate this program in integrated dynamics. Now, folks, this is going to be one of those programmy episodes where we have program stuff and we do programmer things. If you don't want to go through all that and watch exactly how I'm setting it up, I totally understand that. I'm going to put a time code, a chapter. You can go down to the description. You can skip to when it's done. You can skip to the eureka moment. You'll maybe miss all the trials and tribulations as we go through it. But that is sort of what we're going to do for the rest of this episode. So sorry if that's not your cup of tea, but I did have several people ask me for this build after I figured it out in creative. And so I'm also had some help from the Integrated Dynamics Discord that I wanted to, you know, kind of thank people by showing off this build. So, you know, that's what we're doing this time around. So that begins now. If you want to take off, go down to the description and find the time code. All right. So we are going to need to set up this network for logic. And that means a couple things. One, we're going to need to plug in this variable store. And actually, maybe we'll put the variable store. Well, no, we'll leave it down here for now. Maybe even a better place to put it would be right flush with the reactor right here. Now, the other thing that we're going to need to do is we're going to need to ask questions about the redstone flux cell, which is to say the network's energy, as a question. And if you kind of look at the network options, you'll see, let's see, like energy entity store. There's nothing here for there's no option here for like what energy we have stored in the network. That's what a network reader is for. Now, I've actually never used this block before. So that's not what we want. That's not what we want at all. How about we put this here? We break this, and then we go like this. What's kind of cool about this is we've got a network here, an integrated logic network, that looks at itself, and it's going to ask questions about itself. You can see it's got 5 elements. It's got 1 energy battery. It has this much energy stored, this much energy capacity, right? And there's a whole bunch of other things we can ask it about itself, right? Which is really, really cool. So what we're going to do now is we're going to take these in our logic programmer, and we're going to recreate the program that we have on screen. I'm going to flash it again now. Hopefully our editor Dave, please remember to do this. But we're going to have to go through and create each one of those. Now, I have made a labeler. So I'll go through and I'm just going to get my inventory cleaned up. And I'll go through and I'll show you how I make a few of the variables so you can see the process for that. Because I think this mod is super cool, but it definitely is not, I wouldn't say it's like natural and intuitive. You have to kind of work at it to figure it out. And we'll even talk about a functional programming concept in the creation of this. So give me just a sec. All right, folks. I've taken the liberty of installing a display panel. And I'll be honest, I've actually had to do a few takes on this episode. It's tough. Just kind of, we're going to do these in short little segments. If you don't follow along, I think the best thing to do is to look at the program, which I'm going to put up on screen again now, right? And just sort of recognize what that is and what it needs to be and go through creating that. And once you see me make a few variables, I think it'll become obvious sort of how to read that program. So the first thing we're going to do is calculate the fill ratio of the whole network. And we want to do it that way. It's actually kind of weird that this doesn't have a fill ratio. Other blocks do. And you can see, by the way, I voided a bunch of energy so that it's a little bit easier to see what the value is. But let's go ahead and grab this and this. Now we want to divide them by each other. But if we were to do that right now, and this actually has caused a few takes, is that we actually can't because they're huge integers. And if we divide two integers, we get integer math, which of course means that we would get a 0 until it was totally full. And that's kind of not what we want. So what we're going to do is have to cast these to float. You can only see the cast operators when you search for casts. So pro tip there, right? And so we're going to say this is energy stored. Now, if we're holding a label maker, so we can click E. I don't know why, but this is stored. So we're going to say this is FE stored int, right? Yeah. We'll put a thing in here, and then we pull it out, FE stored int. And then this is FE max int. So we'll say FE max int and toss this in. So now we have them in a data type that we can work with, right? So we can say divide. And that means that we can put this here, right? FE stored over FE max. And then we'll call this fill ratio as in the program. Now, we didn't fill in these casts with names, but don't worry about it. Not everything has to match the program for it to work. And then we'll pull this out, and now we have fill ratio. Now, if we place these variables into, we'll put them here on the first line to sort of represent the first part of it. Now, if we put this in the screen, we see 0.25. So we are quarter full, and we have 3 million out of 12 million. Math checks out. So now we have a fill ratio card. Great. What we need to do, though, is not get the fill ratio, but the fill history, right? We want to make sure that things are going up over time. That we actually just need another copy of the energy stored as an int, because we actually want to compute how this changes over time. So if I put this in and then this, now I have two versions of that, right? So one of these, 23, see this is, let's see, if we put this in, it'll be broken. I think we put this one in to fix it, right? So let's make sure that that's still working. This is a delayer. What it's going to do, I think it starts at 5, so let's put it down to 2, is it's going to take the value in here, and it's basically going to make an array. This is energy stored, right? Yeah. It's going to make an array over time of the two values, and we can go ahead and go like this, boop, to grab the delay value. This is a list of length 2 that shows the values here. So we can go ahead and put it on this, right? And we'll just see we're holding at 3 million, because every tick it says, what's the last tick's value and what's the current tick's value, right? So this will let us actually observe the change in the storage over time. And that's what fill history is. So we're actually going to pull this out. We'll use this to call this fill history as for the program, because we definitely don't want to lose this value, right? So we've got the fill ratio. We're going to put this back in here for now, and the fill history that we're going to put that there, right? So the next thing we need to do is basically compute the loss rate. I'm going to take a breath here because this is as far as I've gotten any take. I'm just going to give myself a moment. Let's try to hit the next step. So next we need to compute the charge rate. We have this fill history here, which is the history of the value, and we're going to have to pull values out of it. To do that safely, we have to use this thing called get or default, which basically says pull something out of the list or don't. If I don't use this, then the program that we're writing in Integrated Dynamics will halt when you start the server, because when you start the server, there's no history. That is one of the problems with using a delayer. So I need to make some integers, and then we can basically pull the value out of the list. We want to get the zeroth value of the list and call that a 0. And we'll call this fill history 0. And then we'll get the first value out of the list, or the 1th value, or a 0. We then subtract those two values and call this charge rate. Like so. And we can go ahead and check this out now. It should be 0, and then if we turn it on, we should be able to observe it in the system. So let's just go ahead and put these in, and we'll keep charge rate in our hand. Let's see, did it work? Currently it's 0, that's what we expect. Let's force on the reactor. And look, it's charging up. Fantastic. Next, we'll make the is filling with a greater than operation. So we want to say if charge rate is greater than 0, then we'll compare the charge rate, and we'll basically do all of our range operations now. So we'd like to say greater than, this is our is filling, and this asks if the current charge rate is greater than 0. Then we can ask if our fill ratio is below different percents, right? We can say fill ratio is less than 20%. We can call that below 20. And we could say below 80% with a 0.8. And we could just verify that we shouldn't be below 20 and we should be below 80. Almost there now. So what I need to do is compute reactor keep going, which is an AND, a logical AND. And so we say if we are filling and we are below 80, then we'll call this reactor keep going. This is to sort of define the case where we know we are filling up back to 80%. And finally, we want a logical OR operation, and where we say either reactor keep going or below 20. Let's test this now. This is our reactor on value, the end of our program that we built up, and currently it should be false because by our rules, we're above 20%, we shouldn't be charging. I've disabled the redstone port here. We'll have to turn that back on, but it's off. So let's see what happens if we force this on. It should be charging, and now it knows it's charging and it's below 80%, so it's going to start charging up, right? And this should mean that this value is going up. Now, my theory is that if I were to move this over into the redstone value and then re-enable this, well, we should see the correct behavior. So I'm going to let that happen. It will take a while to fill this up, unless, of course, I pull out this value, these values, right? And I think everything should just work correctly, right? Because we've got this entire system set up dynamically based off the values connected to the network. So let's go ahead and in a moment of truth, let's go ahead and put this in here. This is the Boolean on-off for redstone, right? And as you can see, it's lit up. We'll turn this on and we will save. So now it should be staying on. It should be powering still. I'm going to wait a moment and see what happens. I'm getting kind of impatient because this is a big battery compared to the output that we have here. So let's just try removing the upgrade, right? That will basically make us full, and that should stop us immediately, right? And then the value should turn off, and the reactor should stop. Right? Correct. And you can see it gradually drains out. So there's a moment where right now, if I were to put it back in, it would start back up on its own because it's still draining the battery. But as we can see now that it is basically totally empty, if I were to put this in, oh, it started back up because it drained that last little buffer of power out of the system. which I guess is good in this case, right? But yeah, so folks, I think we did it. I think we have a self-tune reactor. So this episode's, I don't know if it's going to be long or short. There are many, many takes. Thanks very, very much to, in particular, 3 people from the Integrated Dynamics Discord. Sanzeth, who's actually the idea of this type of program. I modified it so that we can talk a little bit about the specifics more. But thank you very much for the idea, Sanzeth, because this is ultimately your reactor program idea. I was going to use a latch or the pulse mode. This is better. Thanks to you also very much to Natalie and Elias, who helped me sort of walk through this and improve some style and tell me about failure conditions in the system. All right, I got to stop myself. I'm excited about this, and I'll do some more work off camera. But yeah, we have a power system that's self-regulating, can accommodate multiple batteries, just does the right thing overall. And I'm excited about that. Now, folks, thank you very much, and I'll see you next time.